Okay, I hope I'm audible to all my students who are attending this particular lecture for the PG Economics CUET entrance exam. In this particular lecture, I'm going to continue with the discussion of the 2024 question paper for the PG Economics CUET exam, which all students can now currently see on your screens. Now, if all students can recall that in the previous lecture, I had solved the first two problems. This was problem one I had solved in the previous lecture, and we had also done problem two for discussion, question number two. Remember, just to revise with all students, that this paper contains 75 questions. For every correct answer, students score 4 marks. For every wrong answer, you lose 1. Okay. The instructions of for all this are given in the PDF version of the question paper, which all students can find on my app. Okay. If I scroll down, we are now going to start with the discussion from question number 3. These are all MCQs. I'm going to start with the discussion of question number 3, which all students can currently see on your screens. So let's start with the discussion of this particular question in this particular lecture. So let's read question number 3. Assume that there are firms I and J, and both these firms have a constant marginal cost equal to C for an identical good in an oligopolistic market. So there are two firms, I and J. Both the firms have a constant marginal cost. Okay, so it's a duopoly. They compete to set the prices PI and PJ. So PI is the price set by firm I, PJ is the price set by firm J. The total market demand is Q. If PI is more than PJ, the demand for firm I is 0. So capital Q denotes the total market demand. If firm I charges a higher price than firm J, then firm I's demand will be 0 because all customers are going to go to that firm which charges a lower price. If PI is less than PJ, the demand for firm I is Q. Whichever firm is going to charge a lower price will get all the market demand, which is Q. If PI is equal to PJ, they share the market demand equally, and hence the demand for firm I is Q over 2. So if both the firms charge equal prices, the total demand, capital Q, will be equally split between the firms I and J. So each firm's demand will be Q over 2. So in equilibrium, the prices of firm I and firm J are what? So this is a question based on the Bertrand. Students who have subscribed to my complete course for the PG CUET Economics entrance exam, you can check out my lecture videos on Bertrand model of oligopolistic competition within my intermediate microeconomics course. We know that in Bertrand model, the Nash equilibrium is when both the firms charge a price exactly equal to the marginal cost. That means the answer for this question is in equilibrium, both the firms are going to charge a price exactly equal to the marginal cost, which is C. Okay, so I can quickly come to the whiteboard and I can just revise the Bertrand model with all students. I am just writing the main heading for completeness. We are looking at PG Economics CUET exam 2024. Okay, we are looking at this particular exam. So we are looking at question number 3. I'm just writing what is given. Okay, two firms I and J. Two firms I and J both have constant marginal cost. Both have a constant marginal cost equal to C. Okay, and we are also given that it's a Bertrand model. We can identify that from reading the question itself. Okay, so clearly this is a Bertrand oligopoly model. This is a Bertrand oligopoly model, which assumes which assumes that the firms compete on prices and not on quantities. So if one of the firm charges a lower price, that firm gets all the market demand. That firm gets all the market demand. So I can say, to avoid undercutting, undercutting means that one firm charges a price, the other firm slightly undercuts by charging a slightly lower price. So to avoid undercutting and losses, both the firms charge a price exactly equal to the marginal cost. They charge a price exactly equal to the marginal cost. Hence, the Nash equilibrium, of the Bertrand model. The Nash equilibrium of the Bertrand model is both the firms PI and PJ. PI is the price charged by firm I, PJ is the price charged by firm J. Both of them charge a price exactly equal to the marginal cost. So I can say that both the firms make zero economic profits. I can write both the firms make zero economic profits in the Nash equilibrium. This is a complete explanation of the question. Although students were just required to mark the correct answer, but I've also given a proper recap of the Bertrand. And again, I'm telling this to all my students. When you subscribe to my complete course for CUET Economics, you will see in depth the explanation for the Bertrand model and Nash equilibrium within my lectures on intermediate microeconomics course. Okay, so coming back to the question paper, let's look at question number 4. So if I scroll down the question paper, question number 4. If y, which is a function of L and K, is a linearly homogeneous production function, when I say it's a linearly homogeneous production function, it means that it exhibits constant returns to scale. Because we have done this in our lectures in intermediate microeconomics, linearly homogeneous means it's homogeneous of degree 1. Then multiplying all inputs by a constant factor 2 results in output to also increase by a factor 2. This is my answer. If I double my labor and if I double my capital, my output will also exactly double, because a linear homogeneous production function is that production function which exhibits constant returns to scale. Okay, so I can come to the whiteboard and I can just write an explanation for this as well. This is question number 4. Okay, we are given that y is a function of L and K, is a linear homogeneous production function. Linear homogeneous production function. Okay, so students should be able to recall from my lectures in intermediate microeconomics. Access for all these courses will be given to students who have subscribed to the complete course for CUET. That a linearly homogeneous production function, a linearly homogeneous production function exhibits constant returns to scale. It exhibits constant returns to scale. That is multiplying, or I can say scaling, all the inputs by a constant factor, scaling all the inputs by a constant factor lambda, results in output also getting scaled up, by the same factor lambda. That is, I can write that if the production function is exhibiting constant returns to scale, f of lambda L lambda k is just lambda times f of k. So if lambda is equal to 2, I can say that f of 2L 2k will be just 2 times f of L. That means if I double my capital and labor, my output will also exactly double. This is the property of constant returns to scale. Okay, so I hope students have understood the explanation. So my correct answer is option 1. If I multiply all inputs by 2, my output will also exactly increase by a factor of 2. Coming to the next question, question number 5. So let's look at question number 5. Okay, so if I scroll down, we are given a game matrix. We are given that there are two firms, firm 1 and firm 2. Okay, and we are given that firm 1 has two strategies: cooperate, compete. Firm 2 also has two strategies: cooperate, compete. In the table above, firms 1 and 2 can cooperate to share the market profits, or they compete with each other. The figures in the cells represent the crores of profits in INR, Indian rupees. They can either cooperate with each other, in which case they are going to share 10 crores equally. So both get 5-5. Alternatively, they can compete, which lowers the market output to 4 crores, which they share equally. So if they compete, they earn only 4 crores if I divide it 2-2. If one of the firm competes while the other cooperates, the competing firm obtains the 10 crore of profit, while the one who cooperates gets 0 profit. So when firm 1 cooperates and firm 2 competes, firm 1 gets 0, but firm 2 gets 10 crores. And when firm 1 competes and firm 2 cooperates, firm 1 gets 10 crores, firm 2 gets 0. We need to again find the Nash equilibrium. So it's a simple Nash equilibrium based problem which we need to solve. So let me quickly come to the whiteboard and let me write this game matrix on the whiteboard, and then let's figure out the Nash equilibrium. This is question number 5. Okay. We are given that there are two firms, and I'm drawing the game matrix for all students. So we have firm. Let me come back to the question paper to see. We have firm 1 and firm 2. Firm 1, and then we have firm 2. Let me write firm 1 a bit here. And the strategies are cooperate, compete, cooperate, compete. If both of them cooperate, they earn 10 crores, which are divided equally. If both of them compete, they earn 4 crores, which is divided equally, 2-2. If one of them cooperates and the other one competes, the competing guy gets 10, the cooperating guy gets 0. Let's figure out the Nash equilibrium. Remember from my lectures in intermediate microeconomics, how we figure out the Nash equilibrium. Okay, so very simple. We see what is the best response of each firm to the other firm. So let's start with firm 1. If firm 1 cooperates, firm 2 will compete. Now let us see what happens if firm 2 competes. If firm 2 competes, firm 1 will want to compete because 2 is more than 0. So I can say that this is not the Nash because there's a tendency to deviate from here. This profile is also not the Nash because when firm 2 competes, firm 1 will not cooperate, firm 2 will compete. Then when firm 1 competes, what will firm 2 do? Firm 2 will compete. And when firm 2 competes, what will firm 1 do? Compete. That means this is also not the Nash because there's a tendency to deviate from. So I can say that I got a dash below both these payoffs. So I can say that whenever firm 1 competes, firm 2 responds by competing. And whenever firm 2 competes, firm 1 also best responds by competing. So therefore, the unique Nash equilibrium of this game is compete. Both the firms are going to. So hoping all students have understood how we have solved this particular problem. So if I come back to the question paper, my answer is in equilibrium, firms A and firm B should respectively compete. This is my answer. They should compete in the Nash equilibrium. So hoping students have understood this. And now we look at the last question for today. If I scroll down the question paper, question 5 we have done. I'm looking at question number 6. Okay, so keeping a consumer's income constant, if bundle X is chosen by a consumer when Y is available, then when bundle Y is chosen, X must not be a feasible alternative. This property of consumer behavior is known as, we all know it's known as the weak axiom of revealed preference, WAR. We have done this in our lectures on revealed preference theory within my lectures in intermediate microeconomics. All students should know weak axiom of revealed preference. If I quickly come to the whiteboard to explain this. Okay, so recall from my lectures on revealed preference theory. Access for this will be given to all those students who subscribe to the complete course for PG CUET Economics entrance. Recall from my lectures on revealed preference theory within the intermediate microeconomics course. Within the intermediate microeconomics course, weak axiom of revealed preference, short form WAR, states that if the bundle X is directly revealed preferred, if the bundle X is directly revealed preferred to bundle Y, meaning the consumer buys bundle X when bundle Y is still affordable. When bundle Y is still affordable, okay, then it cannot happen, then it cannot happen that bundle Y is directly revealed preferred. It cannot happen that bundle Y is directly revealed preferred to bundle X. That is, it cannot happen that the consumer buys bundle Y when bundle X is still affordable at any given set of prices. At any given set of prices. So what we are trying to say indirectly is, suppose I am buying bundle X when bundle Y is still affordable, and when prices change, suppose I now start buying bundle Y, then X should not be affordable. Then what will not be violated? If I switch to buying Y when X is still affordable to me, then there is a problem. What is violated? If I switch to buying Y when X is no longer affordable to me, then what is still consistent? So if I come back to the question paper, when the bundle Y is chosen, X must not be feasible or must not be affordable. Then what is consistent? And that is my answer. If I buy bundle Y when X is still affordable to me, I am going to violate the weak axiom of revealed preference. Okay, so for this, please revise and rewatch my lecture videos on the revealed preference theory within my intermediate microeconomics. So I stop in this particular lecture. We have discussed till question number 6 in this lecture. In the next lecture, I'm going to start with the discussion of question number 7. So I hope all students have enjoyed this lecture. In doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.